Have you ever poured hours into implementing a feature into your game when you really didn't need to? I spent over 2 days rewriting Unreal Engine's GameMode and GameState script from scratch just to realize I'd have to trash it all in the end anyway. And this all started because of one keyword. Literally 4 characters that if I had known to delete would have saved me all that time and over 200 lines of code. So let me show you how I screwed up so you don't have to. I'd like to walk you through how GameMode and GameState are actually meant to be used. This is Qsters, welcome to my first video. First off, when making a game in Unreal Engine that you do not plan on doing any networking, it is really easy to put any variables or functions pretty much anywhere as it is all pretty easily accessible. And that is all hunky-dory, but for those who would like to create a maintainable structure to their game, or for you Vibe coders if you'd like to vibe with your code more, you've really got to worry about what information goes where. And this is especially true when doing networking, when knowing how to do this is basically required. And that brings us back to GameMode and GameState, where this really comes into play. Game modes are defined per level in the world settings and load alongside the map. They get to decide what pawn class you use, player controller, game state, as well as the other framework classes that the level will use. And importantly, in a networked game, game mode only exists on the server. When clients load up, they will not have access to a game mode, so if you need clients to access data or functions about the game, it cannot exist in game mode. Instead, this is where game state comes in. Game state at the surface level doesn't do a whole bunch, but where it really comes in handy is with networking. It is game mode's counterpart that exists on all the devices. The server has access to the authoritative game state, meaning it is the only one that has the true state of the game. And through Unreal's replication system, it sends information to all the clients to make sure that they are informed of, well, the state of the game. This ends up making the game mode and game state classes pretty tightly coupled together. Something I heard once is that the game mode decides and the game state informs. If you know who coined that phrase, please comment it, as I could not find the source of it for the life of me. So one good example is if you are making a 3-player chess game. Your game mode is the rule keeper of the game, and let's say the player on client 2 makes a move. It needs to send a request to the game mode to verify. In this case, sending a packet to the server game state to make the request on its behalf, the game mode can then validate it, and if legal, updates the authority game state with the new state of the board, which then propagates that information to all the players. The game is now in sync, and the game mode has full control over the game. Remember, game mode decides and game state informs. I have found it to be the best way to archetype these scripts in networked projects. Unfortunately, I had to learn this the hard way. At the start of this year, I dove into Unreal Engine 5 for the first time, and about 2 months ago, I started working on my current game. When setting up the project, I created the game mode class and unknowingly made a decision that, along with a heavy dose of stubbornness, led me down this path of pain. See anything wrong with this? Look really close. Pause if you need to. Yeah, there really isn't anything, but in order to understand exactly how I messed up, we have to go into a lower level on how to use game mode and game state. In Unreal Engine 5, every project starts with 2 core classes, a game mode base and a game state base, which provide the fundamental gameplay framework we covered before. On top of this, Unreal has 2 subclasses of those, a game mode and a game state, that implement a match state system and some other niceties. Let's take a look into the implementation of these and how it informs us on some of the best practices. First, in a game mode, it keeps track of the current match state in an F name and has a setter for it. It feels unintuitive at first that the game mode itself holds the state. Wouldn't it make sense to keep track of that in the game state? But stick with me, it all comes together. You will also see a game mode defines 5 F names in the match state namespace that define the basic states it can be in. And it also feels unintuitive at first why they decided to make these F names instead of using an enum. One good reason for that is it allows for runtime flexibility. For example, you could transition to dynamic states that contain information such as round 5, and there's no need to recompile and add a whole bunch of enums for it. It is all controlled and accessed at runtime. Now, as the match state variable and setter are protected, the game mode itself is the only one that can set the current match state, forcing encapsulation so that the state machine only changes when the game mode decides, reducing the likelihood of invalid transitions and making sure that every state change is dictated by the game mode and updated via the setter. In setMatchState, it updates the matchState variable first, then calls onMatchState, which is a handler for state transitions exclusive to the game mode on the server, and then it just needs to inform the game states of that change. A game mode then grabs the authority game state living on the server, calls its setMatchState, informing of the changes made, and inside that setter, it first verifies that it's the authority game state living on the server. It then updates its own matchState variable. Finally, it calls this function onRepMatchState. In order to understand exactly what's going on here, we have to get into how the server game state updates variables to all the clients. In order for any variable to sync from the server to its counterpart on the clients, it first must be replicated. Setting a variable to be replicated via the uProperty macro means that whenever the property is updated on the server, it will automatically create packets to send to all the clients. In this case, with matchState, Unreal has specified a replication callback function, onRepMatchState, so that whenever clients receive an update packet, that function is called. Here, the function is used as a handler for state transitions that happen on all the devices. So again, let's walk through the flow from beginning to end here. The game mode decides to switch states to round 1, calling setMatchState on itself. It updates its own matchState, calling its transition functions that need to happen on the server through onMatchSet. The game mode then grabs the game state and informs it of the update through setMatchState. GameState then updates its own matchState variable, which due to the replication system starts the process of the packets being sent to the clients. Then it manually calls the onRep function. This is because it will only be called automatically when the clients receive those new packets, but not on the server as it already has the authoritative matchState. So the server has to call this manually to get those transition functions in GameState to be called on the server. And then the packets are received by the clients, they update their matchStates, which then calls the onRep function on their end. And now the server and clients are all in sync and can continue playing. Of course, there are probably 1,000,001 different ways to archetype all this. This isn't the only method by a long shot, but if you follow this design pattern, I will promise it will make networking your game so much easier and safer. And you've seen the tip of the iceberg here with how matchState works, but a game mode also handles player logins, aborting matches due to errors, and reconnecting players. There's a lot of stuff in there that will make your life a lot easier. Of course, when I was designing my game, I had no idea about any of this, and well, this is how that went down. When I was creating my game mode class, I had not done any research, and out of ignorance, I chose to inherit from a game mode base, not knowing about any of these features in a game mode. So I kept developing my game mode class, fumbling, refactoring it, and eventually it allowed for some clunky networking. And I get to the point where I wanted to implement a state system, so I could make an actual game loop for the game and get some playtesting done. It was only at this point when I thought to do some research and finally learned about Unreal Engine's A game mode class. I studied how its state machine worked, and I looked at my class and I saw it would take a lot of refactoring to get it all to work. And like the fool of a toque I am, I thought, I could do better. So I spent several days learning, recreating, and integrating my own version of A game mode state machine into this massive script. It was a pain, though I did learn a lot. So a week or two later, I created this channel and started streaming on Twitch and YouTube. I was literally on stream showing how I implemented my own system, and I started thinking how I could make it cleaner and more presentable for the stream. And I realized Unreal Engine already has a class with all this functionality from the beginning. I didn't need like 200 lines of this code. It was literally 4 characters that started me down this path, and admittedly a healthy dose of my own arrogance and stubbornness kept me on it, and it was not worth it. I decided to share myself learning and making another system which leverages what Unreal Engine has already done. I created a tutorial project and called it Tori. I plan on doing all my tutorial videos in it, and maybe over time it'll actually turn into something functional. Subscribe if you're interested in learning how I ended up designing in a future video, or check the description for a link to the Tori Life playlist. If you have any thoughts on how to make it better, please put them down in the comments, or feel free to join me on the stream and give me suggestions there. I'm gonna guess that I can reduce this by 200, maybe 300 lines of code, and then I'm curious if AI can beat that and reduce it even further. If there's one thing I would take away from this, it would be game mode decides and game state informs. And to do like 2 minutes of research before committing to writing hundreds of lines of code for no thrice forsaken reason.